Right, good morning, everyone. Hopefully you can hear and see us. So, a quick introduction. I'm James Barry. I'm the Deputy Chief Exec at the Property Care Association, and you join us for what actually turns out to be our 51st webinar by my crude maths this morning. So we have what I think is a really interesting presentation for you. If you've seen our presentations before, they've all been very good, but I really think this one's going to be really thought-provoking. I always like to do the technology ones, so this is a good one for me to be doing. And I'm very pleased to welcome Owen Jenkins from Nationwide Drones. So we're going to start, as you all filter in, I'm going to do a bit of an introduction to who we are, because this is a webinar for members and non-members. Obviously the members are going to be aware, but for those that aren't aware, we're a specialist trade association for building specialists that deal with defects in the built environment primarily. So today we're going to be looking at drone technology in the built environment, and we're going to start by checking that you're all engaged, you're all awake, and we're going to start with a bit of a poll. So we're going to see sort of how widely this technology is used in a professional capacity. So Harry is hopefully going to put out a quiz and find out what sort of experience you've all got with drones in a professional capacity. So if you do that, and while we're waiting for you to answer the question, I'm going to ask Owen to introduce himself.
Yeah, that's great. Thank you, James. So my name's Owen Jenkins. I'm Managing Director of Nationwide Drones. My background is primarily in building surveying and property inspection across the UK. Nationwide Drones as a business, we are primarily service the building surveying firms, facilities management companies, social and private landlords, housing associations and registered providers. And we offer, as the presentation will sort of go into detail, we offer a broad range of services, primarily aerial drone related, but we also do some ground-based and internal inspection and scanning services. Yeah, look forward to showing you what we can do, and look forward to the end when you can send in your questions, whatever they might be. I think on looking at the poll, it's fairly balanced at the moment, so it's generally 50-50 of you, 50% of used drones in a professional capacity before. In our experience with the clients we're working with, generally the industry is probably nearer the sort of 70-75% mark for drone use. But that doesn't necessarily mean that those companies are using the broad range of abilities and capabilities within the drone technology. It might be just a small drone to send up in the air to take some inspection photos. So we'll go into a little bit more detail on more of the capabilities of the drone. So I'll kick straight off. So what we're covering today, so benefits obviously of drone surveys versus traditional methods, and we've got a background in undertaking both. The technology that currently sits behind drone surveys, any limitations, the permissions required to enable us to do what we do, and the requirements for individuals to fly. In addition, the data that we capture and how we process it. Then we'll start sort of deep diving into the more heavyweight mapping services utilizing photogrammetry and LiDAR. And then how we create our 2D and 3D digital models, and then use that digital model to inspect, create reports, more traditional reports in sort of PDF, and also how we've more recently been adopting AI and machine learning to undertake inspections for us and our clients. Then we can look at the advancements around the imagery for inspection. We use 360 orbs rather than flat images. how we can then report on that data, how scalable the technology and innovation is, cost, conclusion, and then we'll look at a QA. So basically, drone technology has very much revolutionized many industries. Like I said, we primarily are focused on the built environment. So we work with building surveying practices, FM, social and private sector landlords. We do a lot of roof surveys, as I've alluded to on the slide. So we'll start sort of diving into the benefits and what sits behind this current drone technology, and later we'll talk about what the future short, medium and long-term advancements look like. And there's a very nice image of a saturated flat roof for you. So the benefits of drone surveys versus traditional methods. I mean, some of them are fairly obvious, but environmental impact, no need for scaffolding, heavy machinery. In most cases, there's much less sort of planning and design and RAMs that are required for undertaking drone surveys versus the traditional methods of inspection. Cost effectiveness. I suppose this is it's in most cases, I'll say, because there are certain cases, mainly outside of our sector, where drone technology can become quite expensive. But in our sector, it definitely reduces labour costs, the requirements of time on site, and obviously the necessity for access, such as scaffolding, mutes, cherry picker scissors, scissor lifts, etc. Accessibility. As would be probably quite obvious, the drone can get into very, very hard to reach places without the need for specialist equipment. In some cases, we find ourselves inspecting sort of historic buildings and churches, church spires, culverts, say, and they're sort of areas you'd never send people, so they very rarely get the level of interrogation that they need from a survey perspective. And there are specialist drones and cages that you can put the drones in that enable this. Safety, pretty obvious, reducing the requirement to work at height, which, as you'll probably be aware, is that one of the biggest issues from the HSE for accidents at work. Again, referring to the requirement for scaffolding, ladders, harnesses, utilising man-safe systems, etc. And then efficiency, we can, I'll go into the detail a bit further along, but we can cover much larger areas using automated missions, and the quality of the imagery we can capture versus traditional methods is much higher in resolution. Versus obviously the traditional setup and requirement for inspection using telescopic poles, ladders, access, etc. Drones can collect an abundance of data, and this helps reduce the possibility of missed data and revisits to site, which obviously cuts down on time and cost, and improving the customer experience. So the technology behind drone surveys, again, some of it's quite obvious. High resolution cameras. I'm sure you've all seen drone photos. Bottom left image, that's basically an automated map that's been set up above, looks like an industrial park. Sensors, so there are a multitude of different sensors that can be fitted to drones. You tend to find the sort of plug-in chop and change sensors tend to be on the larger drones. So there you've got a selection of different high resolution cameras with maybe telephoto lenses, depending on the use case, but also you can fit thermal sensors, so we can fly the drones at night to identify areas of excessive heat loss within buildings, roofs and elevations, but also those thermal sensors can be used to fly over solar panels in the daytime. It's the only time you can use a thermal sensor on a drone in the daytime is to inspect overheating or redundant solar panels on roofs and at solar farms. LiDAR, which is laser scanning. We use that from a ground-based perspective inside and outside of buildings, but we can also fit the same sensor to a drone and capture aerial point cloud data that can then be combined with the ground-based data to create a 3D model. GPS and mapping software. So this enables the digital model to be produced from the air, and then that data to be geotagged. So if you wanted to tag defects or areas of interest or areas requiring repair, and then share those actual geotag locations with supply chain, subcontractors, workforce, etc. You can do that, and it's generally we find a majority of the work we do, the data is processed in the cloud, so it's very easy to share on a web-based platform. Doesn't require any specialist software to view. And also automation. I'd say at the moment, we're probably 75–80% of all of the flights that we undertake are automated flights. So they're pre-planned in the office. We look at, we plan them on a GIS map or on Google Earth. We mark out where we're going to be flying the drone, as is shown on that picture on the bottom left. So when the operator turns up at site, they just do a very basic on-site risk assessment. They set all of their kit out, they set the drone up, and they press go, so they don't have to intervene, and that obviously drives efficiencies and the quality and the accuracy of the data, very rarely requiring a revisit to site. So the limitations of drone surveys, physical interaction. Obviously, we can't lift tiles, we can't prod and poke the fabric of a building, so we can't check using the human hand and the human eye. Also, weather dependence is a pretty significant thing. The bigger the drone, generally, the more inclement the weather it can fly in, but there are obviously limitations. Think when you're capturing images of a roof, say in an automated flight, and there's a wind gust of above 25–30 miles an hour, that can just throw off the sensor ever so slightly. So when you get back to the office, you process the data, you can just see some drift in the imagery. So we try to avoid certain weather conditions. Some of the drones are water resistant, so they can still fly in the rain, but generally with rain comes a bit of wind, and wind tends to delay or stop us going ahead with some of the drone surveys. And battery life as well. So the bigger the drone, the bigger the sensor, the windier the conditions, the larger the site, the quicker you can burn through sets of batteries. So we did a topographical survey of a site that was probably about 45 acres in Herefordshire earlier on this week, and we had to move ourselves around the site and change batteries as the drone was coming back, burning through various sets of batteries. Generally with roof inspections, congested sort of areas, smaller, medium-sized commercial buildings, it can all be done within one flight. So obviously, in order to counteract that, we have to carry multiple sets of batteries. We have charging units in the back of our vehicles, but yeah, it can get a bit clunky on the very large jobs. So permissions and restricted flight areas. So basically, we're governed. Drone operations in the UK are governed by the Civil Aviation Authority, so they impose fairly strict regulations on when and how drones can be flown. So where we have to be very conscious is congested urban areas near airport and restricted areas such as prisons seem to be quite a large one at the moment for various reasons. Generally, if we're flying within a controlled flight zone near a prison, we have to give a minimum of 28 days notice. This can sometimes be reduced depending on the type of relationship we have with that airspace operator. But obviously, if we have a client that says they need an urgent roof inspection, they're in a flight restriction zone, then obviously it becomes very difficult to be able to fly a drone within the strict regulations. So it's all about planning, to be perfectly honest. It's about managing the expectations with the client, getting them to understand what the restrictions are and why they're there. And just obviously, the sooner we can get applications into restricted airspaces, the better. The sort of caveat to that is an OSC permission. So an operational safety case is basically where a drone operator spends a fairly significant amount of time operating in these heavily regulated sort of areas, and builds up a portfolio of projects that have been delivered in difficult spaces with complex planning. And then that drone operator can put in an application to the Civil Aviation Authority for a specific operational safety case to enable the operator to fly in a smaller space, so take off and land from a smaller space, fly closer to a building, fly lower, so capturing much better quality imagery and better resolution images, and also to be able to fly closer to people and crowds, which is a pretty important thing, especially in congested cities and towns. And on the right hand side there, you can see that's actually a copy of our operational safety case, and that, as you would probably imagine, it's about a 50-page document with all of the sort of different restrictions and caveats to our authorization. So in order to fly a drone, as I've alluded to, so obviously we need permission if it's in a flight restriction zone. Most of the flights that a drone operator undertakes isn't in the flight restriction zone, so we just do a very basic desktop check. But the essential permission is permission to take off and land from the landowner. So a landowner's agent can act on behalf of the landowner, so they can give us the permission. But that's absolutely essential. So you cannot just turn up and take off from a street or from a pavement. You have to be taking off from an area that where you've got permission. In the case of taking off from a street or from a pavement, we need to apply to the local council to ask for permission, and it's pretty much similar to the process of flying in a flight restriction zone. The other sort of key point, or we do it as sort of best practice, is inform the police. So there are various examples I can go into, but if we're surveying for a housing association or a council high-rise blocks of flats at night with a thermal drone, the likelihood is that residents, tenants are going to be quite inquisitive as to what we're doing. First things first, we'll notify the police and we'll get a police number confirming with them what we're doing, what we're undertaking, our level of qualification. We generally share a copy of our RAMs, our risk assessment and method statement for the work that we're undertaking, so they are aware. And then in the event that we get any disgruntled people coming over asking why we're flying a drone around their property at late at night, then they can either call the police and get reassurance, or we can call the police, and the police will, in some cases, come out and actually chaperone us while we're doing the survey, because generally the surveys are no longer than 45 minutes to an hour, depending obviously on the size of the asset that we're surveying. It's just best practice. The police are very, very used to drone operators, making them aware of works that they're undertaking in certain areas. So requirements to fly. So obviously top left, landowner's consent I've already gone into. That's absolutely essential. Operator ID. So basically every drone operator in the UK must have an operator ID, and that ID is generally attached to the drone at all times. Usually we use a very small sort of ticker tape to permanently apply that to the drone. Bottom left is the drone code. You can just Google drone code, and that's the very sort of basic generic legislation for flying drones. It also goes into the detail of where that sort of grey area between the very, very small drones, so the sub 250 gram class of drone that's being used by a hobbyist, where it sort of starts to move above that weight and you become more active in the commercial space. Again, it is a bit of a grey area, but ultimately as a commercial operator, regardless of the unit that we're flying, we still need to go through the same processes as if we're flying a very large drone, as if we're flying a small drone. We still need permission to be able to do what we're doing. We still need to notify the authorities if there's a restriction zone. We still need to notify the police if we're flying in an area where especially where we feel there might be some resistance. Bottom right is the flyer ID. So every pilot has their own number, like a driving license, and they get that once they do their theory test. Now, currently, and it's inevitably going to change over the course of the next few months and years, the civil aviation have a theory test, which is basically an online test. It's multiple choice sort of questions. It's fairly straightforward. It's not very, very easy, but if you've read the drone code and you have a fairly basic understanding of drones and you have some common sense, it's a pretty straightforward thing to pass. For us and our company, and I think most commercial operators, it doesn't even come close to the level of experience that a drone operator would need to operate in the commercial environment. So this is where we're going into more around the required training for our pilots. So for a GVC qualified pilot, there's the theory exam, which is online, but more importantly are the practical flight assessments. I think it's really, really important that a professional appraises and assesses the abilities of every individual drone operator, and moreover assesses their ability flying multiple different types of drones, because they have different handsets, different types of controllers. As you might have seen, I think the poll is still showing 50% have used the drones in a professional capacity. In some cases, the controllers are quite small and you actually clip your phone onto the top of them. In the case of the larger, more professional drones, it has a standalone handset that's got a screen on it. And obviously, it's really important that your operators are assessed on their ability to fly the drones that you actually utilize. And then the other key thing is your operations manual. So this is before we get to the stage where you go for a full operational safety case. You need to have an in-house operator's manual that's written for the company, showing and stating exactly what you will do in the event of every single project that you work on. So it'll state who your pilots are, what their level of qualification is, the insurances. An example with the insurances, we're starting to do quite a lot of work with inspecting the assets owned by Network Rail. They require a minimum public liability insurance policy of 5 million. In most cases, clients require a minimum policy of £1 million in public liability and £1 million in professional indemnity. But all of these things need to be checked and they need to be referenced and stated within your operations manual. So before the GVC, the GVC qualification, which is our minimum level of qualification for our drone pilots, we go into the advanced stages of flying the drones. So BV loss, you might have heard of, is beyond visual line of sight. So that enables the pilot to fly the drone as you would imagine beyond the visual line of sight. So before having the advanced training and then adding the BV loss element to your operations manual, the drone operator must maintain visual line of sight of the drone at all times, which sounds quite easy and quite straightforward, but it's not, especially if you're flying a very, very small drone. It's quite easy to lose sight of the drone when you're flying at 50, 80 meters above a building doing a roof inspection, especially if the weather's a little bit cloudy or misty. It can be quite difficult, and not that we've had this experience ourselves, but we know of other companies where their operators have essentially lost the drone, and because the weather's maybe a little bit inclement, they've lost connection between the controller and the drone, and the inevitable happens. No one knows where that drone has gone, which is obviously a bit of a no-no. The larger the drone, the easier they are to maintain visual line of sight. And then advanced flight training. So learning how to safely control a drone in instances where the pilot loses GPS and enters ATTI, which is the manual flying mode. So what they essentially do is the assessors will turn off all of the lovely safety and automated control elements, and the pilot has to bring that drone back into land from a fairly difficult position manually. So even though, as I stated earlier on in the presentation, a majority of the flights that we undertake are automated, every single pilot still needs to have that fail-safe in place to enable them to fly the drone manually and land it in a safe space in the event that all of the safety and GPS goes down. I have to say we haven't experienced losing the GPS and the ATTI, but obviously, we need to make sure that we've got that safeguard in place. So civil aviation permissions and restricted flight areas. As I've alluded to before, the Civil Aviation Authority have imposed strict regulations on when and how drones can be flown. This includes restrictions on flying over certain urban areas near airports and in other restricted zones, which can limit the ability to conduct surveys in these locations. Airports are probably the biggest sort of case with restricted airspaces, because they cover quite a lot of the UK. Airports generally are our friends, because the airspace is controlled. When we make contact with an airport wanting to fly within their restriction zone, number one, they're used to drone operators applying for permission to fly, so they have a fairly robust sort of form-filling exercise, or a phone call through to the flight operator, and then they'll give us a time slot when we can fly. But actually, because that space is controlled, it actually helps us, and it gives us a more sort of robust structure around what we're doing and in what areas. If you try to fly a drone in a restricted area, you won't be able to take off, because in the restricted flight areas, they have the ability to ground drones, and they connect with the software that we use for flying the drones. So the handset will not allow you to take off. So mitigation with this, obviously, is just careful planning. I'd say in most drone operations cases, we spend as much time at our desks planning the operation, making contact with the relevant bodies to get permission to fly, as we do going out on site, setting our stall out, taking the drone imagery, checking it, and leaving site. In some cases, planning can take weeks and weeks and weeks to undertake a drone inspection that might be 30 to 40 minutes on site. So it's really important that we do all of the legwork, all of the grunt work when we're in the office before we get out on site. The OSC permission, so gaining the operational safety case to operate in some of the restricted zones, can expand the operational area. But this process can be time-consuming, costly, and complex. So, to give you an idea, I'd like to think that we're in a fairly well-respected, credible part of the industry as a commercial drone operator that's been operating for 6 years. It's taken us a year to get our operational safety case, and it's cost us a significant amount of money. And working with the Civil Aviation Authority is quite difficult. It's it can be likened to maybe trying to communicate with HMRC. As a government organisation that definitely haven't got enough staff, you have a tendency to submit your application for your operational safety case, so stating to the Civil Aviation Authority what you've done, proof of that, and what you intend to do and what you'd like to apply for, and then they can come back and say, well, we're not happy with this component in your application. You address those components, you resubmit, another 28 days of waiting, and they'll come back and they'll have picked up 2 other issues that they weren't flagged up originally. So it's quite a frustrating process, but it's something that we just don't have any control over. We're really happy to have already gone through that, but it's something that needs to be conscious of. It's not simply a case of submit your operational safety case and your fee, and you sort of keep your fingers crossed and hope for the best. It's a lot of back and forth. We've not heard of anyone that's submitted their paperwork and immediately been granted an OSC. So I think everyone has the same experience. So just pop on to the next slide. So standard commercial permissions. So this is the non-operational safety case commercial permissions. So this is under what's called the PDRA, which is predefined risk assessment. So it's basically automatically granted by the Civil Aviation Authority. And so these are the standard authorizations to fly unmanned aircraft below 25 kilos within visual line of sight. Remember what I said about BV loss, which is beyond visual line of sight, which is an advanced level of training to enable you to do that. And these are at residential, commercial, industrial and recreational areas. So the commercial permissions are, you must keep the drone within VLOS, so within visual line of sight. Operator ID has to be labelled onto the drone. You have to conduct a short pre-flight risk assessment, so it's not too dissimilar to if we were surveying a property with traditional methods. You'd still turn up, you'd do your basic risk assessment checks. It's broadly similar to what we do with the flight checks. So we'd be looking for overhead cables, weather conditions, crowds of people, any areas that we can't control. If there's anything from a risk perspective from people, we tend to just walk away from the job. It's just not worth being a pilot with a drone in the air and then getting hassle from people. And it has happened, and I'm no doubt that it will happen again. If you're flying with a screen or a camera, you must have an observer present next to the pilot to keep the drone in visual line of sight. So this is where it becomes quite strict. So if you're flying with a smaller drone with a small controller with your phone on the top and you're staring down at your phone, you're not maintaining visual line of sight of the drone. So obviously you would need an observer to maintain that visual line of sight of the drone. It's very, very difficult. And as you would imagine, as if any of you are hobbyist drone pilots, you've no doubt flown your drone looking down at the camera and it's all fantastic, but in a commercial operation, that isn't within the confines of the standard commercial permissions. You can fly up to 120 meters. I don't know about you, but I struggle to see 120 meters, so it's quite high up. Don't fly close to people. That's just common sense. Don't overfly crowds. So I think there have been quite a few instances recently. I think there was the Taylor Swift concert down at Wembley where someone flew a drone over Wembley, obviously highly illegal. And I think the police have already found out who it is and they'll be prosecuted. So it's just too dangerous flying a drone over crowds. There are levels of permission that certain operators can achieve to enable them to do this, but it's generally the police and it's generally at sporting events. Obviously, keep away from flight restriction zones or seek permission. So I think the three key ones there. So airports and prisons. Airports, from a permission perspective, we've got quite a good. We're based in the Midlands, so we've got quite a good relationship with Coventry Airport and with Birmingham Airport. we can generally give them 48 hours to 72 hours notice, and we'll be okay to fly. But if you look at through their paperwork requirements, it's a minimum of 28 days for Coventry. I think the first time we applied for permission, it took us 28 days. Since then, obviously, they're familiar with the business and the way that we operate. You can sort of bring that time down. Prisons, as yet, we haven't been able to get permission from a prison with less than 28 days. As you would probably imagine, prisons have an absolute nightmare with people flying drones around for various obvious reasons. So again, it's back to the point of planning the mission in, spending the time at the desktop, utilising the various different softwares that are out there, processing the job through the software and looking at the limitations. In some cases, where we're flying, doing, say, a commercial roof inspection on an industrial estate, they're generally quite close to a major highway or to the railway lines. In the case of a roof inspection, we can often get away without requiring advance permission from Network Rail or from the rail operator, just by flying maybe 5 meters closer to the building than we would normally. Obviously, we can then lean on our operational safety case to enable us to do that and still give the client the level of quality and accuracy they need from an inspection perspective. In the event that the drone needed to be sort of flown further away from the roof, we would have had to apply for permission from Network Rail to be able to fly nearer the railway lines. Again, as I alluded to earlier, we're actually starting to do quite a lot of work directly for Network Rail, but their requirements for drone operators are pretty significant. So it's just to fly some of their sites near to live railway tracks, again, is 28 days worth of notice, and a very, very robust risk assessment and method statement, and obviously the enhanced public liability insurance as well. Do not fly where you'll disturb or endanger animals and wildlife, and caution around sites of special scientific interest. You'll probably have seen signs out when you've been on holiday where no drones. There are definitely a lot more areas that are no drones. That could be due to nesting birds. It could be due to the fact that they have a lot of tourist activity during certain times of the year, and it's just too dangerous. And also flying near the coast, you tend to get a lot more wind gusts, and they're very, very difficult to control the drone. Yeah, again, it's all about the planning. Generally, any asset that needs inspecting, you can find it on the map, on the software. You can draw an orb around that asset, tell the software what you want to do and what height you want to be flying, and it will tell you what you need to do, what applications you need to put in, whether you're too close to any restricted flight areas. Also, and we have had experience of this, are there any other aircraft present? So that's not just drones. It could be microlights. It could be fixed wing drones. It could be in a flight path. So that's really, really important. The airspace everywhere is just getting more and more busy, especially with the advent and the advancement of drones and drone technology. Shockingly, you can still go into high street stores and buy professional drones. And the capabilities of professional drones are far beyond what you can do with what we deem and the civil aviation deem as hobbyist drones. But it doesn't mean you don't need a license to buy them, which means that some people, some entities think that they can just fly them and get away with it. So know the limitations of the drones. I've already touched on this before. So wind speeds, temperature restrictions, so very hot, very cold weather, etc. It can affect the battery capability on the drones. Being conscious, being aware of this beforehand means you can mitigate that and plan it out. So taking more batteries with you, having some sort of charging capability whilst out on site, especially when you're doing larger mapping missions. no cargo on drones, so you're not allowed to carry anything on drone apart from the fixed sensors that can be swapped out on the larger drones. Pilot fit and ready to fly, again, common sense. Yeah, you don't want a drunk pilot, you don't want a pilot that's struggling with their eyesight or have turned up to site without their glasses or their contact lenses. Again, very, very basic things, but very, very important. And insurance, of course. So our clients tend to dictate the level of insurance we need as a business, and there are very distinct business insurances. So there's the business insurance that I'm sure all of you will be familiar with: public liability, employers' liability, professional indemnity. But what you tend to find is they won't cover the drone operations. There will be an additional policy to cover your drone operations, and then the requirements of that drone policy will be dictated either by the types of projects you're working on or by the client requirement. Again, in the case of Network Rail, they need a minimum of 5 million of public liability. In the case of some of our larger multidisciplined surveying consultants that we work with, they need a minimum of £1 million of professional indemnity. I think it's overkill, but it is what it is. So we need to make sure that we've got that in place. And as you would imagine, it's not cheap. And quite a few insurers actually that were in the drone market going back a couple of years, they've actually pulled back out of the market. So it's becoming increasingly difficult to get the level of insurance required to fly some of the more complex missions. So enhanced permissions require approval. So again, we're now going to the really sort of professional end of the scale where we've got our operational safety case. So this sort of gives you a snapshot insight of the difference between a standard permission and an operational safety case, or specifically our operational safety case. Every operational safety case can be different from a company to company basis, but this basically allows us to fly more complex missions, allows us to fly closer, nearer to more restricted areas and separation from uninvolved people. So in the case of a standard permission, maximum operating range is 500 meters away from the operator. We can fly to 2,000 meters, and because we've got the advanced training and beyond visual line of sight, we actually can fly much larger missions over longer distances without the need for spotters at 500-meter intervals, which is obviously quite costly, sending additional operatives to site. Separation from uninvolved persons at takeoff and landing. So whereas prior to the OSC, we needed to maintain a 30-meter distance away from people who weren't involved in our operation. So to give you an example there, if we're surveying a house, and we're doing elevations and a roof inspection, the people inside the house, we will have notified them, so they are involved. But an involved person could be someone walking down the street or someone turning up on the next door neighbour's drive. So yes, we've got all boards out telling them what we're doing, and there are drone operations, and we have a safe takeoff and landing area. But it's quite difficult to maintain that within 30 meters. So with our OSC, we now have to only maintain that within 5 meters. And then during flight, it's a 50 meter, so it's even more difficult once the drone's in the air, and we're down to 10 meters on that basis as well. So yeah, it's quite restrictive, the standard permissions, and getting the operational safety cases has opened up a huge number of additional opportunities for us as business. And as I've mentioned, separation from assemblies of people. So if you're flying near a crowd with non-OSC, you need to be at least 150 meters away from them. We can fly up to 50 meters away from large crowds of people. So pre-flight planning and post-flight. So with pre-flight planning, as I've said, a lot of the heavy lifting is actually done by the software, but then it's also really important that we can locate other elements that might influence the job going ahead while we're on site. So we would undertake a site-specific risk assessment when we're at the site. So the software can't tell us that, and obviously we'll only find that out once we get to site. Confirm your takeoff and landing locations and an emergency landing position on a map. So it's always good to have a backup, because in the event that the area that you've taken off and you've allocated for taking off and landing becomes unviable, then there has to be an alternative. Weather forecast is absolutely essential. Again, we have software that can tell us what the forecast is on that day and that time, and it can essentially notify us if any of that changes before the job goes ahead. We generally review a job the day before, because if we're having to travel to site and it's quite a distance, we have the ability to call off and change the date of the project with obviously no charge to the client. But if the client overrules us and says, no, I want you to come to site and at least try it, then they burden that cost. You have to ensure your drone software is up to date and make sure that your controllers are all up to date with the most recent version of the software, because the Civil Aviation Authority and the restricted airspaces, they can change what they're doing and not notify anyone, and they generally will send out their updates or any restrictions to the newest version of the software that the operators are using. Goes without saying, is your drone fit to fly? So checking that all the batteries are working properly and they're charged up. Checking propellers for damage. Making sure your connections are working properly on your and your GPS is working properly on your controller. Make sure your return to home works. That's pretty easy. We test all of our drones on a weekly basis and ensure all the emergency safeguards work. And also, it's important to set your height and distance limitations within the controller. So basically, if you fly, if the operator flies the drone too close to the building or near to too close to the building, depending on whether we're flying under the standard or the advanced OSC permissions, the controller can notify the operator. Because when a drone's in the air, it's very, very difficult to look up and say, oh, it's about 20 meters away from that building. It's very, very difficult with that perspective to guess, so that we can set the controllers to notify us of that. And pilots must achieve a minimum flight time of 2 hours in the last 3 months. It's obviously not difficult for us, but for some of our clients who have adopted drone technology, bought themselves a small drone and are taking photos, say, of roofs or high-level elevations, it might be a little bit more difficult to maintain that. It's basically like a drone pilot CPD. And then post-flight, we have to record all of the flight logs. So every single flight we undertake, no matter how short, no matter how long, where the location is, we have to submit logs and the times and the weather at the time. We have to record inspection and maintenance on all of the drones and report any dangerous occurrences, near misses, or suspicious activity. Thankfully, we don't have to write too much of that up. Insurance to fly commercially. So I think I've already covered this off. So it just goes into a little bit of the detail around the general business insurances, which you'll no doubt be aware of. But also there will inevitably be an additional level of public liability for drone use. We're being asked for the specific drone public liability insurance more and more now, which is really good, which means that our clients are more aware that the general combined business insurance policies don't cover the drone operations. And then also there are NOTAMs. So this is where there are official notices that can come through on your controller to say that this is going to affect your flight. So tower cranes are obviously a pretty big one, especially when we're inspecting construction sites down in London, because there are tower cranes everywhere. There could be a parachute jump that's taking place. There could be a kite up in the air, rocket launches. Again, rocket launches generally, we've not had any experience of that. But if there is an aerial activity that's taking place that isn't available on the software during the planning process. It could be sent through to your controller on the day or even during the flight. So again, it's just a notification process of other things to be aware of when you're flying your drone. So data capture and processing, this is where it gets interesting, and I am conscious of time. So we can capture high resolution imaging, very, very high quality videos, 4K quality is as standard. Some of the other sensors that we work with, hyper and multispectral images. So with the spectral imaging, we can basically scan large areas of land and identify invasive species. As an example, we did an 80-kilometre stretch of HS2 for Kia Effiage, and to identify Japanese knotweed and ash species, so that they could then map that, and then that would better inform their ecology team to actually go and do what they needed to do to protect or remove those species. LiDAR, as I mentioned at the very beginning of the presentation, we use the LiDAR sensor where we need much more accurate geometrical data from the scan. So if we're doing a topographical survey of a parcel of land, and especially if that parcel of land's got any dense vegetation, the LiDAR scanner can give us much better ground accurate dimensions than using photogrammetry. So in standard format, say for a roof inspection, we use photogrammetry, which is where essentially we set the automated map of the asset. The drone flies in a grid format, backwards and forwards, and then oblique, and then those images are stitched together in the software, and then points of reference, so geometrical points of reference, are captured through the overlapping of the images. The more images you take, the more accurate that data is, and it enables then the client to be able to geotag that data and also measure very accurately in 3D. So you can measure pitches of roofs, you can measure elevation heights, and obviously you can measure spans, etc. So data processing. So obviously we use software to stitch images together to create 3D models. Bottom left, that's a row of terrace properties in Birmingham. That's captured through photogrammetry. So what you're seeing there are hundreds and hundreds of images that have been stitched together to create a 3D model that's fully measurable, and you can annotate it. Everything is stored in the cloud. So we can process data while we're out on site. Using 5G tethering or Starlink, depending on how heavyweight the data is. The data outputs that are available, obviously media, aerial photos and videos. We have an in-house editing team for producing very cool videos. Photogrammetry, as I mentioned, is the general process we use for inspection and creating measurable data. So again, this just goes into a bit more detail around photogrammetry, LiDAR, and the benefits. In basic terms, photogrammetry is fairly cheap and cheerful, and gives a good level of accuracy. LiDAR is sending a laser scanner into the air, so the data is much more heavyweight, takes a lot longer to process, but the quality and the accuracy of the data gets much closer to traditional methods of surveying. Let's see, I'll very quickly go on to the AI and the inspection tools. So we've just started using some automated AI tools from NVIDIA, as you can see on the bottom. So whereas traditionally in the drone sense, we'd go out, we'd scan a building, we'd map the roof, and then back in the office, we'd process the data, and then one of our building surveyors would mark up, that's a cracked tile, that's missing mortar or lead flashing, etc. Now we have the opportunity, and the future is going to be an AI tool. So we, through machine learning, we tell the tool, this is a cracked tile, this is missing flashing, and then we run it through 1,000 images, and then it'll identify it and flag them up, and then produce the report off the back of that. So that's going to be the most exciting sort of medium and long-term future of drone technology for inspection. We also use a lot of 360 imagery for inspection. I am conscious of time, James.
I think we might have to, because otherwise we're not going to get time for a Q&A, and we've got a few questions lined up. So do you want to sum up this slide, and then we'll jump very quickly into Q&A?
Yeah, so with the 360 imagery, we tend to create inspection orbs, so they're 360-degree images above each of the assets, and that just better informs the building surveyor to inspect that asset rather than using flat images, which can be quite restrictive, and they don't give a good enough context. But anyone who's interested in an example of that, I've got a web link. We've got web links on our website where you can actually go and interact with the imagery. And this is just an example of a report that we've produced on the right-hand side, where it flags up the exact location of the defect, the type of defect, showing it in a broader context. Obviously very scalable. We can undertake 2 or 3 commercial roof inspections a day, whereas previously it would be 2 or 3 days to undertake an inspection and draw up the report. So the scalability of drone and the technology that's associated with the inspection has just changed the game now, and obviously driven down the actual cost as well. Which is exactly what the next slide comes on to, is the cost now is so much lower. So we're undertaking a lot more inspections for chartered building surveying firms, producing the report from an inspection perspective, and then they'll produce the recommendations for their clients off the back of that. So drones enhance safety, efficiency, and cost savings, and the AI and machine learning piece is something that we're all really looking forward to further improve the efficiency and improve the cost savings for our clients.
Thank you very much, Owen. The AI and the use of drones, I think, is an area that we want to explore, and perhaps we'll do something where we can expand on that perhaps at another time. I'm conscious we've got a couple of questions here that I want to put to you before we run out of time. The first is it a mandatory requirement to obtain a GVC certificate for all drone types commercially, and if so, when did this become a requirement? So
actually with the GVC now, it is we can't get insurance for our operators without the GVC license. So it used to be the A2C of C, but as a commercial operator running under an OSC with the requirements, insurance requirements of our clients, we need a minimum level of a GVC. You don't need the advanced level of training, but if you want to, the further and further we go down the rabbit hole of drone technology and the innovation, the more likely it is that all operators will require a GVC minimum. But it's not a requirement of the Civil Aviation Authority. Requirement of the Civil Aviation Authority is the A2C of C, which is a much more sort of lightweight version of licensing. But just as best practice, every operator really should have a GVC, because it's sort of like it's like the proper driver's license for the drone, the commercial drone sector.
Thank you. Next one. I've seen exclusion zone maps for airports, but how close is it regarded for prisons?
So each prison's actually different. So if you go on to the flight restriction zones on Google, it'll actually show you per prison. I think the one we're doing, Durham University campus at the moment, which is part of it is in a restriction area, and I think we're about 250 meters away from the prison, but it still falls within that threshold for requiring application. So we've put that application in already, and again, we've been told 28 days. We're hoping that it's going to be a lot less than that.
Yeah, perfect. And the third one I've got here, how will Amazon starting to deliver parcels by drone impact the drone workplace community?
So what Amazon are doing, and they're not alone, the NHS have been doing blood deliveries, is they're working under an operational safety case. So they've got an agreement with the Civil Aviation Authority to enable them to fly within certain areas with certain restrictions. We're finding a lot of this, and they're only under trial at the moment. So Milton Keynes, Oxford, Reading have got essentially their own controlled airspace areas for the trial of beyond visual line of sight flying. So that generally their areas. Bristol, I know, has just signed up to one as well, because one of our colleagues has been flying down there. I think more and more of these areas, these controlled airspaces, will be set up where they're controlled and monitored, and there's a very, very robust level of interaction with the drone operators that fly in those areas. But they'll be flying under an operational safety case, so very, very specific set of sort of flight restrictions, and ultimately that will hopefully sort of build the flight space to the point where the whole of the UK will be, you'll be able to fly beyond visual line of sight, but it's going to take quite a while.
Very much, and bang on time. So thank you very much for that, Owen. So I don't know if my
I think, James, you might have gone off. If anyone else has any questions and they want to send me an email, it's owen@nationwidedrones.co.uk.
Thank you very much, Owen. Can you hear me this end? Is it
yeah, we can hear you. Yeah, I think it's your internet that's lagging.
No, fine. Okay, well, I will wrap this up very, very quickly. The last thing I would like to remind people of is we have the International Property Care Conference coming up at the 18th of September. We've got a new venue, the Telford International Centre. We've got a cracking lineup there, and we'd like to see you there. So if you haven't booked your ticket yet, please do. And just to wrap up, I'd like to say a massive thank you for Owen for coming and agreeing to do this. And I'd like to sort of continue some other conversations about how we sort of develop drones technologies in the built environment, and AI and digital twinning, etc. as well. So thank you very much, and goodbye all.
Yeah, thanks very much, everyone.